You've learned PLC basics, memory, edge detection, and timers. Now let's take it one step further. Today, you'll learn how to use IEC 61131-3 counter function blocks for tracking real-world events like product counts and machine cycles. There are 3 counter types in OpenPLC: CTU for counting up, CTD for counting down, and CTUD for both directions. The counter either increases or decreases its value whenever its input changes from true to false. By default, counters use a 16-bit integer, which limits you to around 32,000 counts. If that is not enough, you can use larger counter types like dint for 32-bit values, or even lint and ulint for very large ranges up to 4 billion. The up counter block has a digital input CU that increments the counter value CV by 1 whenever its signal changes from false to true. The output Q becomes true when the counter value reaches or exceeds the preset value PV. The counter value resets to 0 when the input arrow is true. Now add the contact to the counter input and assign the button 1 variable to it. Add a coil to its output with the LED variable. Assign the button 2 variable to the counter's arrow input and 3 to the PV input. Then ensure that the PLC simulator is selected in device configuration and start the simulator. Force the contact to true and then release the force. Observe that CV is increased by 1. Do this a couple of times and observe that when CV equals PV, the coil is made true. Forcing button 2 to true resets the counter to 0 and sets its Q output to false. Stop the simulation and replace the up counter with the down counter. Assign the button 2 variable to the LD input and 3 as the preset value. The down counter has a digital input CD that decreases the counter value by 1 from the preset value on each rising edge. When its LD input is true, the preset value is loaded into the counter. The output Q becomes true when CV is or below 0. Start the simulator. Observe that the LED is already true since the CV is 0. Force button 2 to true and release the force to load PV to CV. Force button 1 to true and release the force to decrease the counter value. Repeat twice and observe that when CV is 0, output Q becomes true. These counters can be used to track a machine's countdown to maintenance. Stop the simulation and replace the down counter with the up-down counter. The up-down counter combines the functions of both the up and the down counters. It has the up counter CU input, which increases the counter value, and the down counter CD, which decreases it. It has a common preset value that makes the up counter output QU true when PV equals CV, with the arrow that resets CV to 0 and makes QU false. The down counter LD input also loads the PV to CV when true, and when CV is 0, its QD output becomes true. Now assign button 2 to the counter CD input and 3 to the PV input. Add an LED 0 variable to the QD output. Then update its location as QX0.1 in the variable table. Go to Device Configuration. Select the ESP32S3. Refresh and select the correct COM port. Map the LED 0 variable address to pin 6 of the ESP32. Then compile and upload the logic. Now connect an LED to pin 6 of the ESP32. When button 1 is pressed repeatedly, the first LED lights up after the third press. Similarly, when button 2 is pressed 3 times, the second LED lights up on the third press. This could be used to indicate whether a parking lot is full or empty as cars enter and exit. That is all for today. In the next video, we will see how to integrate an LCD using a custom function block. Please like, comment and subscribe to this channel if you have not. See you in the next one.